Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Welcome everybody, this is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany. I'm right now here again in my cramped study recording a video interview remotely from DATAbility, the startup of the month, July 2020, within our media partnership with Frankfurt Forward. Therefore, I would like to welcome Sebastian. How you doing?
Hello, Joe. I'm doing great. Thank you. And thank you very much for the congratulations and for having me in your podcast and vlog.
Totally my pleasure. For everybody who's watching this on YouTube or listening to it on some streaming website, podcasting site, go down here and make sure you like and subscribe. That said, you are Startup of the Month, July 2020 by Frankfurt Forward, and I've been stalking you a little bit on LinkedIn. Everybody who'd like to reach out to you, they can of course find the link, your LinkedIn profile down here in the show notes. But for me, it was interesting to see that you actually just came out of university, so to say. Your research associate still there, and basically you founded DATAbility straight out of university. There's so many options here in Rhine-Main getting well-paid jobs. What was the driver that you said, okay, let's do a startup, let's be risky?
Yes, great question. So I studied mechanical and process engineering at Technical University in Darmstadt. And after that, I stayed there at university. So I joined the group of Professor Klinghauf. It's the Institute of Flight Systems and Automatic Control. And connected with this is the intention to become a doctor in engineering. So I am still working on this, and I want to submit my dissertation this year. And during my studies and also my doctorate, I was involved in developing machine learning frameworks and apply machine learning algorithms in industry, most often in the aviation industry with our project partners. So does my co-founder Christian too. So we developed machine learning frameworks, so-called digital twins, for example, to assess and predict the remaining useful lifetime of a mechanical component, say an electric drive, for example, or bearing. And my work is dedicated to the use of machine learning models for fuel efficiency assessments of aircraft. So, we gained a broad experience in these research projects and developing machine learning frameworks. And from our activities, the idea was born from my side to work in this field and in my own company. So I asked Christian, my former fellow at university and my former colleague and my former supervisor, Professor Klinghauf, if they could imagine founding an own company and to do this. So I prepared the startup for, I would say, 1 year and a half beside my employment at the university. And then we are funded in August 28. And I left university this year. And Christian worked there already for 2 years in DATAbility.
Whoa, a lot of information. Let me put this in perspective, because there are more than 80% of our audience is from outside of Germany. So going for a doctorate means you are still a PhD student, right?
Yes, it's not basically a PhD program like in other countries. So we work at university as researchers, having our own research project with industry, and we have the possibility to hand in a dissertation. Most often it takes 5 years at university, and at TU Darmstadt, then we have to leave university and go out into industry.
I see. So dissertation means some PhD programs that you have to publish like 3 or 5 papers in international journals, but that means you have to write basically a book about one topic, right?
Yes, that's right.
Okay, that's it. So basically, you've been working in aviation fuel efficiency. That sounds very technical and very mathematical. Can you give us a little bit of a connection to like the real world where this actually applies? Because I assume you're looking a lot at MATLAB, Excel sheets, statistic programs and stuff like that.
That's right. Yeah, maybe you saw those interesting looking wingtips on an aircraft. So on the outer side of the wing. And you can apply their new wingtip fences. So these you can retrofit onto older aircrafts. And with this measure, you can become a more sustainable aircraft. So it contributes to a reduction of the fuel consumption. And in best case, this reduction is about 4%. But these are estimations from suppliers, and it's very difficult to quantify those saving potentials for a dynamic flight environment with changing environmental conditions and for a specific airline operator. And for the quantification of such measures, I use machine learning, and that's what it's all about with my dissertation topic.
Oh, I see. And I would assume there are many, many, many variables you can include in such assumptions. I would assume, for example, if you fly with or against the jet streams, that makes a big difference. If you have to fly around like thunderstorm or something, that also, or through even a thunderstorm, that may change a lot if one of the engines doesn't work properly. So there are like endless possibilities, right?
That's exactly right. So you can measure a degradation effect with the lifetime of an aircraft, and you can quantify with such digital twins, measures an aircraft and to quantify the potentials and to sell those measures better in aviation industry.
You're talking about digital twins. Can you explain for everybody, like including me, who's never had something to do with either aviation or digital twins, what one has to assume a digital twin looks like?
Yeah, so we gather data out of a technical system. So basically, the data consists of temperature sensor readings, vibration, for example, fan speeds or core speeds of an aircraft engine. And with this information, we set up a model. And the model is based on machine learning algorithms. And with this we call a digital twin. In my case, for my dissertation, a digital twin for the operation of an aircraft. So it's literally, it's a calculator to calculate the fuel flow for the aircraft engines. And you do not build this up with the classical engineering approach. We call this white box modeling. So there you have statistical, mathematical, or physical models to calculate the fuel flow. We build this up on a data-based strategy. So we're getting data out of the system of the aircraft, and then the machine learning framework will train those interdependencies, calling the correlation between flight altitude, speed, maybe the wind speeds of the jet stream, to calculate the fuel flow, and it train itself iteratively.
What just came to my mind, we're talking about jet streams, but we have not explained it. You are more the specialist. Can you tell us a little bit about jet streams?
Yeah, those are specific wind fields in the upper atmosphere. So, as you said, if you fly against them, that's not so good for your fuel consumption. But if you fly with them, you can faster approach your destination and you can save fuel with or without wind potentials.
Oh, you call it wind potentials. For everybody who was getting nervous a little bit when flying like commercially at the time before coronavirus, can you tell us a little bit with what type of margin of safety usually the commercial aviation airlines calculate? So it's not like you arrive when you fly from Frankfurt to like New York with the last drop, but there's a margin of error. How large is this usually?
For the fuel consumption, I guess. Oh, you have a great margin. So you have requirements from regulations from the European regulatories or from the FAA in the States. And you calculate your fuel, say for an Airbus A320 or a Boeing 787 Dreamliner, for a specific city couple. I want to fly tomorrow under certain weather conditions from Frankfurt to New York, and you have a calculation tool. And you have a lot of overheads. So at least the pilot can say, no, I want to take 1 or 2 tons of fuel more with me. Maybe the weather is changing a bit faster than predicted. And so you have a high safety margin in this. So, but that will come to my dissertation topic. So you get a lot of reducing potential. So to reduce those not used the aircrafts fly a lot of with overweight of fuel, and they carrying fuel from A to B. So you have a lot of high potential to minimize those unused fuel.
That all sounds very, very interesting. One last question before we leave a little bit aviation and get into what you guys are actually doing and offering. Does it really make sense, like only from your area of expertise, like efficiency of usage of fuel, to fly a A380 like the largest Airbus?
Can you specify your question?
Does it make sense, like like in terms of per passenger, is it more fuel efficient to fly with a very small aircraft or with a very big one like the A380?
Okay, yeah, it depends on the how the aircraft is seated. So if you fly an Airbus A380 from Frankfurt to Hamburg, and you only have it is seated with 120 passengers or around that, then you have a bad fuel efficiency on that aircraft. So it's like we driving our car. It depends on the load of the car, how much passengers we carry, what we have for applied engines, and so it depends. Not easy to say, but yeah.
I see. So basically you're one of the guys trying to make this even more efficient, how much a aircraft should or could load in additional fuel. Is this about right?
In principle, yes. So we want to quantify the efficiency of a specific aircraft, so not the Airbus A320. We want to quantify the Airbus A320, the tail sign Charlie Yankee or Charlie Alpha, a bit better with a digital twin.
What does this Charlie Yankee or Charlie Alpha mean?
So the airlines operate a whole fleet of Airbus A320 aircraft. So you have different aircraft in those fleet of the Airbus A320, and everyone has a specific tail sign, call sign, that pilots are using to communicate with airports and so on. And the common calculation methods are calculating the fuel consumption of a Airbus A320. And the digital twin on the upper side calculates the fuel consumption of the Airbus A320, call sign, for example, Charlie Yankee for a Lufthansa airline.
Oh, let me wrap this up. Disclosure, I've never heard this before and I'm not an engineer, but for my understanding is you go from the heuristic level down to specific level. So from A320 for Lufthansa, you go down to like a specific, if I understand it right, Charlie Alpha, the individual machine, like a plane, and you start kind of rebuilding this in a digital manner for all the means of fuel consumption, and then you start calculating this on an individual basis, because some of the A320 will be more or less efficient in very small terms, and you actually take this into your model. Is that true?
That's fully true. So perfect sum up. And yeah, the machines are equal in terms of it's an aircraft, it's a production machine, and so on. But they are so individual, so you have to calculate them on an individual basis. Yeah.
How individual can a plane be? Because I assume like all A320 are built more or less the same. Maybe in this year there's a little variation there. If it built in 2018, 2019, there's a small improvement. 2020, there's like a very small improvement. And then over time you get additional spare parts. This is changed, that is changed. And that's where the differences come in?
Yes, it depends on the entry into service. But all the Airbus A320s, for example, are operated differently in the different airlines and also from different pilots. So you want to phase this into your digital twin to make more precise, more accurate calculations with the digital twin.
So it would also make sense to have like digital twins of the respective pilots and their, I would say, flying behavior?
Yes, you could name that so, but that's a bit difficult, especially here in Germany. So, we have strong regulations on that and regulatories, how to track pilot A and B and his flying behavior. So,
Sorry, I'm a really curious. Okay, totally understood. So, but theoretically, you could do that. I'm a very curious guy, and I have like a question where your models can apply and can't apply, because I was spending time in Africa, and we've been flying around Zanzibar archipelago, so all the small islands around Zanzibar, and there you have very, very small planes. Actually, they looked at me and said, you have to sit there due to the balance of the plane and stuff like that. And then you have like the huge A380 where actually I don't really matter if I'm in or out or where I'm located, and everything in between, as well as helicopters and different types of planes. Where can you actually apply your models?
Yes, you have will have a minimum amount of data from your aircraft because of flight data recording. So the so-called black boxes for the aircraft, there you get data even crash occurred or whatever, but you have the same on different aircraft. So you store the data on the aircraft and you can assess the data and build up those digital twins. So it's all about the digitization of the aircraft. If you have more information, more sensors of the aircraft, then you get probably a more accurate model of your aircraft.
Let me tease you just a tiny bit with the model. Could you also given enough data, like have something like a helicopter or even a blip, an airship, actually validly predicted?
Yes, in my research, I also done this on a helicopter system with together with Airbus, and the results were the same. So it's easy applicable if you have the data of the system, and it's more accurate than conventional strategies to calculate your fuel flow. Yeah.
Ah, I see. So basically, we've always been talking like commercial airlines, especially Lufthansa, like the big flag carriers, but you could also apply it to like local airlines, smaller planes, like down to Cessnas, down to helicopters where they're commercial operators. And I would assume you could even apply it to like cargo airlines, or even the military may be interested in it.
Yeah, that's right. It's all about the digitization status of the aircraft. So if you have the sensors on the aircraft, then you have the data, and then you can build up such database models. Yeah.
Ah, I see. Well, we've talked now about almost 20 minutes about airlines, different types of planes and their fuel consumption. Sorry to be a little bit geeky from time to time, but let's talk a little bit about DATAbility. How many people are you, and what you guys are looking for?
So currently we are 3 founders. So we founded with our doctoral father from university, and my co-founder Christian and me, and we have our first employee. It was a former master student of us, and now he's also in our startup, and we also work with another freelancer from our former institute. So we're 5 people up to right now, and what's our future plan is we are developing our software solutions like a spare part identifier application. And we are looking for strategic partnerships on the one side. We want to have more customers. But we also are looking for maybe a funding or a strategic partnership, let's say with a business angel, to get a greater network to sell our solutions. And so when you're interested to getting into touch with me, then contact me. Yeah.
Would this be something like a Series A, so your product is ready and you only need like the right connection, the right channels to sell it globally?
Yes, that's right. So that's for our software as a service application to identify the right spare part of a machine on your smartphone or smartwatch. We are funded, or since our foundation in 2018 back again, we are funded internally with projects with industry partners. So, and the software as a service solution arise of one of those projects, and now we want to sell them, and it's more scalable like our project business, and therefore we are looking for funding because we have coming up with tackling development costs of the solution to sell this and to build up the training of the models full autonomous, and therefore we are looking for funding.
I see. Questions for me would be now, you talking a lot about airlines. How did the current coronavirus and the like almost shutdown of international travel, how did it hit you and how did you deal with it?
Yeah, to be honest, our so we have different customer types in DATAbility. So we're working most of the time with mechanical and plant engineering manufacturing companies. And to be honest, Corona, the impacts of the lockdown due to the coronavirus affected us, significantly. So fortunately, not physically, but on the business side. So when the situation here in Germany worsened and the lockdown threatened, we directly witnessed how corporate companies and our potential customers reacted. And yeah, we were confronted with a cash out stop of the corporates, and also 2 of our projects were cancelled. So despite the fact that they have already been processed in the purchasing department, they were cancelled. So, and the time at the beginning of coronavirus here in Germany was very difficult for us because all fairs were cancelled. And that was really bitter because we would have exhibited at the Hannover Messe. It's the greatest fair here for mechanical and plant manufacturing and engineering, and also at the International Aviation Fair in Berlin in May. So yeah, it was also difficult to reach out the right contact persons and potential customers in the organizations. And so in one way or another, it was bearable, especially that everyone felt that way, I would say. But nevertheless, we learned a couple of lessons during this interesting time.
Mm-hmm. I see. So basically it did not, but so far it did not threaten the existence of your company.
No. So that is very good. Yeah.
We are recording now for approximately 25 minutes and we're getting closer to the end. So since we are here recording this in media partnership with Frankfurt Forward, I was wondering, what means Frankfurt or the Rhine-Main area, since you guys are based in Darmstadt? What does it mean for you?
Yeah, so I grew up in a city near Frankfurt and left for my studies to Darmstadt, the city. And yeah, I like the city of Darmstadt and the surroundings here very much. Also, I like living here. And during my employment at the university, I also funded a family here. So that settled me here. And Christian grew up here. So we are, located here with our company. And I often get the question why we're not moving to Berlin, because it's the city of startups. So yeah, it's because of our target customers are based in this area, in the Rhein-Main-Neckar region, and also in the south of Germany. So for our startup, it's a very interesting point to locate our company here. So we have Frankfurt 30 kilometers away. So traveling in Germany and in Europe is very, from a central point of view, possible. And also the emerging ecosystem of the startups here is very promising for us.
Yeah, I know what you say about promising startup ecosystems. We track this with Rhein-Main VC as well as in Startuprad.io. And it really feels like there's something moving here. That said, moving is a good word. Let's move on. Say thank you very much and all the best for you, your company, as well as your little family. Thank you very much. It was just a pleasure having you here in the interview.
Thank you very much, Joe. The pleasure was on my side.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.